Hi guys, I'm Kyle and this is my short presentation on sound waves. So I want to start by saying that sound waves are pressure waves or longitudinal waves, and they're a bit different than the waves that we usually visualize in that longitudinal waves are waves where the vibrations take place in the same direction as the advancement of the wave. So normally we visualize waves like on top of the surface of water. If you throw something into the water particles move up and down, but the wave is actually moving from left to right, and that's not what we see here. Here, our particles and our wave move in the same direction. So we have our particles moving from left to right, and our waves are moving slowly from left to right. To see this a little bit more of this in action and have this explained a little more clearly, I've taken a quote from an article that I was reviewing, and it says to imagine one of the prongs of the vibrating pitchfork swiftly advancing. So we have a graphic here of our pitchfork that I've also taken from the article. So the prong of the fork, it swiftly advances, compressing the air immediately in front of it, and when it retreats, it leaves a partial vacuum behind, the process being repeated by every subsequent advance and retreat. The whole function of the tuning fork is to carve the air into these condensations and rarefactions, and they, as they are formed, propagate themselves in succession through the air. A condensation with its associated rarefaction constitutes a sonorous wave. So here we see just that happening. We have our pitchfork vibrating back and forth very quickly, and as it moves, it pushes forward and it compresses that air, and it moves back and leaves a partial vacuum, a space where the air is not compressed. And we can see that happening down here in this same graphic. This would be the pitchfork moving in slow motion. So it moves forward, compresses air, and then it moves back, leaving a little bit of space, a rarefaction, and then it creates another compression. And so our sound waves are measured from compression to compression. So from this C to this C would be one wavelength, from this C to this C, so on and so forth. So you measure longitudinal waves from one compression to the next. And last but not least, mediums. Gotta mention mediums when we're talking about sound waves. So all sound waves need to travel through some sort of medium. They cannot travel through empty space. So you can't hear sound in space where there are, no gas particles, no liquids, no solids. Sound can travel through all three of those mediums, but it cannot travel in a vacuum where there is nothing present, because there are no particles to move. So here's an illustration of an experiment where you have a glass jar covering a bell, and when there's air inside the jar with the bell, exactly what we were viewing on the last slide happens. The bell rings, it creates vibrations in the air, and we can hear the sound. However, if you were to take that same bell in the jar and vacuum pump all of the air out of it, we can't hear any sound. And that is because there's still vibration happening, but there are no air particles to move. So there are no waves to create. It's just vibration happening in a vacuum, and we can't hear that. So to recap, sound waves are longitudinal waves, meaning that the vibration of the particles takes place in the same direction as the advance of the wave. So our particles and our actual wave are moving in the same direction. Sound waves are produced when a vibrating body creates compressions and rarefactions in the particles surrounding that. So it could be a solid, liquid, or gas. Sound can travel through all three of those mediums as long as we have those compressions happening. One compression and one rarefaction together make up a wave, and our waves, longitudinal waves, are measured from one compression to the next. And finally, all sound waves need to travel through a medium. And again, that can be solid, liquid, or gas, but it's got to have a medium, or there are no particles to vibrate. That's the end of my presentation. Here are my references, and I hope you enjoyed. Hope you got something out of it.